Hi class. In this lecture, I want to move on and talk about a different type of counting method called permutations. Now, I'm going to show you how to do these calculations by hand, but I'm also going to show you how to use your graphing calculator to do this. So as you go through this lecture, you might want to have your graphing calculator handy and pause the lecture and get your graphing calculator ready and work it out with me and follow along. Okay, so what are our objectives for this lecture? So we want to use the fundamental counting principle to count permutations. We want to do what's called evaluate the factorial or factorial expressions. We want to use the permutations formula. And then the last thing we're going to do is we're going to find the number of permutations of duplicate items. Okay, so what is a permutation? A permutation is an order arrangement of items that occur when no item is used more than once. So after you select an item or you order it, you can't use it again. And the order of arrangements makes a difference. So like if you're going to do a race and there's two people running, Matt and Steve, the order Matt, Steve is different than the order Steve, Matt. So different orders there. So order matters. Okay, let's do an example with the counting permutations using the fundamental counting principles. So you need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books? Let's assume that the order that the books makes, assuming that the order of the books makes a difference to you, okay? Well, so you can choose any of the 7 books for the first position on the shelf. This leaves 6 choices for the second position. And then after the first 2 positions are filled, there are 5 choices for the third position, and so on. So using the fundamental counting principles, if I have 7 options for the first, then 6, then 5, then 4, then 3, then 2, then 1 for the last option, number of different ways you can arrange these objects, you just multiply them. So if you go 7 times 6 times 5 times 4 times 3 times 2 times 1, you get 5,040 different ways that you could just arrange 7 books on your bookshelf. Now this is assuming the order mattered, which is crazy. It got pretty big really fast. All right, so this product, 7 times 6 all the way down to times 2 times 1, is called 7 factorial and is written as 7 with an exclamation point. So whenever you see this exclamation point behind a number, it's the factorial definition. And if n is a positive integer, the notation n exclamation point reads n factorial. This is the product of all positive integers from n down through 1. So like if you saw 10 factorial, that would be 10 times 9 times 8 all the way down to 7 times 6 times 5 times 4 times 3 times 2 times 1, so on. 0 factorial, by definition, okay, is always equal to 1. So whenever you see 0 factorial, that just equals 1. And similarly, 1 factorial, that also equals 1. All right, so before I show you these, let me show you how you can use your calculator real quickly to do this. So looking back, we know that 7 factorial is this number, 5,040. So if you grab your graphing calculator and you hit this math button on it, math right here, there's all these things, and then over in the top you'll see something called PRB. If you scroll over to it, option number 4 looks like the exclamation point. So if you want to do 7 factorial, type the number first, 7, hit math, go over to PRB, go down to 4 factorial, and look, your calculator does it really quickly for you. Let's do some examples real quick on here. So, and I'll show you how to use your calculator for this. If you wanted to do 8 factorial divided by 5 factorial, well, 8 factorial is 8 times 7 times 6 times 5, 4, 3, 2, 1, which is 5 factorial, divided by 5 factorial. Well, if you do that, notice the 5 factorials cancel out, and you're just left with 8 times 7 times 6, which is 336. But you can also do this in your calculator. Watch. 8 math factorial divided by 5 math factorial. And look, 336. So your calculator can save you a ton of time. So look, we'll look at the next one. Instead of even doing it out, 26 math, PRB, option number 4, factorial, divided by 21 math, PRB, factorial. Look, 7,893,600. You get the same answer with your calculator. All right, so this brings us on to what we call the permutations formula. So the number of possible permutations of R items that are taken from N items. So this would be like if you have 10 items and you want to pick R of them. Okay, so pick like 7 of them. So like 10, pick 3, right, is given by the following formula. So this formula is read as NPR or NPick R objects. So this is where the order that you pick them or the order that you arrange them is important. This is just n factorial divided by n minus r factorial. All right, let me give you an example. All right, you and 19 of your friends have decided to form a business. All right, the group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can these offices be filled? All right, well, how many of them are you? Okay, so your group is choosing 3 people, a CEO, an operating manager, and a treasurer. Okay, so that's your R, the number of people you're picking. From a group of N is equal to 20 people, all right, because there's you and your 19 friends. Now here the order matters because if you pick first to be the CEO, that's different. You have different responsibilities than the person who's picked second to be an operating manager. So the formula here then would be I have 20 people and I want to pick 3 of them. Well, just applying that formula, it's the n factorial, so the 20 factorial, divided by n minus r, so 20 minus 3 is 17 factorial. Now you can see that 20 times 19 times 18 times 17 divided by 17 factorial, these 17s cancel out. And then you're just left with 20 times 19 times 18. Or you can use your graphing calculator to solve this really quickly. So if you go back to the math button, under PRB, you see this thing called NPR. Look, NPR right here, the 20 pick 3. So if you want to use this in your calculator, what you have to do is you have to type the first number first, 20, hit math, go over to PRB, scroll down to number 2, and then pick the number of people that you want, which is 3. Well, look, you get 6,840, 6,840. Wow, look, works out perfectly. So your graphing calculator can do this for you instead of trying to do this by hand. Okay, let's move on to one last example. And this is using a formula for permutations when you have duplicate items. Okay, so the number of permutation of n items where p items are identical, q items are identical, and r items are identical. So the number of ways you can select n items in which order matters, okay, where these objects are identical, are given by, well, you take n factorial, you divide it by p factorial times q factorial times r factorial, how many ever there are. All right, let me give you an example of this. In how many distinct ways can the letters of the word Mississippi be arranged? Okay, like how many different ways could I arrange this name of a state? All right, so the total number of letters in this, okay, so the word contains 11 letters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where there's 4 I's, there's 4 S's, there are 2 P's, and there are 2 R, and there's 2 P's, excuse me. I was going to say and there's 2 R's. Okay, so there's 4 P's, 4 S's, there are 4 I's, 4 S's, and 2 P's. So the number of different ways you could arrange this. Well, if you just take n factorial, which is 11 factorial, and divide that by 4 i's factorials, the 4 s's factorial, and the 2 p's factorial. So I'm going to show you how to use your calculator for this one again. So it's 11 factorial, so 11 math factorial divided by. Now you need to put the denominator in parentheses. So it's 4 math factorial times another 4 math factorial times 2 and then math factorial. Close the parentheses and look, you get the same thing. So you're going to want to try to use your calculator as much as possible on these problems.